I feel particularly honoured to be invited to talk to this very first AME conference. I was the president of MA quite a long time ago. Looking at all of the, is it Mick or Mike? What are you calling them? Mix, the mix. I see that the primary and early years group is up there at the top. And I think the primary and the early years group, which we started as an MA group and then became an ATM group as well, started about 20 years ago. And that was also at about the same time that the first discussions happened to talk about bringing together the different organisations together. And I know that because I was there at the very first meeting, which shows how old I am. Curriculum design, I can't share the details, but we're going to do some maths first, and I hope that the maths that we're going to do will lead us into understanding something about the decisions that the curriculum team have been talking about and are hoping to make as we go along. So first of all, and I apologise if you've seen some of these before. I know some of you will know if you cut me open, I say enrich, 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 enrich all the way down. So here's an enrich game. So would you like to, first of all, say hello to the person next to you? And when you've done that, would you like to draw a box like that? Okay. So, using the digits 0 to 9, no repeats, would you like to put a number in each one of those 4 boxes? Okay. Here are my numbers, and if I read across, I've got 46 and 32, and if I read down, I've got 43 and 62. So if I write them together and add them up, I get 183. Would you like to see what yours add up to? Okay, can anybody beat 183? 194. Any advance on 194? 195? 196. I knew John Mason would get there. Sorry, say it again. 228. Okay. John, do you want to say anything about that? Okay, so what about the smallest number that you could possibly make? Would you like to think about what could be the smallest possible total that you could make? 93, 83. Any advance on 83? Sorry? 49? 39? Anything less than 39? Okay, so what I'd like you to do now is to talk to your new best friend and talk about how you knew what numbers to put in and where to put them. Either to make the smallest or to make the biggest number. Okay. So quite a lot of conversations going on. What sort of rules do you have to use in order to know where you're going to put the numbers? Anybody like to offer me something? Sorry? Big value? Place value, yeah, okay. So top left-hand corner is probably the most important. Why? It's only in the tens, and it's in the tens twice. And conversely, the 2 is the one that has the least power, because that's going to be in the units twice. Okay, so I'm going to leave you with a little question, which is, I think you've all worked out what the biggest number is and what the smallest number is. But my question is it possible to make all the numbers in between the smallest number and the biggest number? And I'll just give you a couple of minutes to have a think about that. Okay. So this is something for your journey home on the train. This is something for your journey home on the train. Is it possible to make all the numbers in between? If it is, what was your strategy? If it isn't, why not? Don't tell me now. I don't want to know. If it is possible, what's your strategy? If it's not possible, why isn't it possible? I wonder what sort of thinking you did when you were working on that. I think you probably did some exploring. Did you do some exploring? Conjecturing? Some conjecturing? Questioning? Of each other, maybe, or of yourself? Explaining? It's difficult to explain to yourself. That's why it's nice to be working with somebody else, so that you're putting these things into words. What about some generalizing? There's something about knowing the top left-hand corner was important and the bottom right-hand corner. Those are sort of generalizing things, aren't they? Convincing? Did you have any arguments with anybody? Did you have to really persuade somebody that what you were saying was right? Justifying? Some justifying? What about proving? Well, I've just offered you one, which is if it's not possible, can you explain why? And if that is so, then there might be a proof in that. So this idea about having lots of different ways of thinking and lots of different ways of reasoning and lots of different ways of communicating is absolutely central to the way in which we should be doing maths. Sometimes it's not always there and it's not always central. Let's have another look at a question. So these two graphs are graphs of Olympic records. So the graph 1 is, can you all see the numbers? They're a bit small. Up the side, it's got 0, 2, 4, 6, 8, 10, 12, 14, and across the bottom, it's got the years in 20s, 1880 all the way up to 2020. So what I'd like you to do is to have a chat to the person next to you and tell me what event each of these represent. Goodness, what a lot of conversation. So I don't want you to tell me the answer for a minute, okay? What I'd like you to do is to think about a statement you could tell me that helps you, that has helped you to know what the item is, okay? So what clues are there in the diagrams that have helped you? Anybody? Okay, they both started before the 1900s, so they're not any of the newer sports, like the half pipe or something like that. Yes, Andrew.
Something gets smaller probably a time.
Okay, do we agree with that? If it gets smaller, it's possibly a time, and if it gets bigger, it's possibly a distance. Do you agree with both of those statements? So again, sorry? Some records stood for longer periods than others. Any other comments? There are some gaps. I wonder what might have happened then. Maybe war? Yeah. Okay, good. The left hand, the vertical scale, looking at those units gives you maybe some indication of what sort of thing we're measuring. Do you want me to tell you? Well, I'm not going to. You can look it up on Enrich, where it's called Olympic records. Okay, here's another thought. Which of those did you use this time? And are there any I haven't captured? Hypothesizing, lovely. Experience. Is experience a sort of thinking? Applying. Noticing. Sorry? Contextualizing. That was certainly what we were doing in this last one, wasn't it? A lot of contextualizing in this last. Any others? Sorry? Attention. Okay. Okay. Now, this last one is hard. Oh, wrong way. So one of the other projects I was involved with, which some of you who are post-16 teachers may have heard of, is underground maths. And this is a question from underground maths. It's been slightly changed. We call it teddy bear. You can see why. So my question is, can you identify which circles are represented by those equations? Well, it's hard, isn't it? Why is it extra specially hard? Because it's impossible. Why is it impossible? Could you explain that a bit more? And can you explain that, why those first three equations are the ones that are at the centre? Lovely. So wasn't that a fiendish thing to do? Yes. Horrible. But it's really good, isn't it, to do that sometimes? When the students are absolutely certain that they know all about this and they can solve it, and then they have something that they go, I don't understand this. Why? Why is this happening? And just really pushes them to really go a bit deeper in their thinking. So I won't tell you the answer, but if you want to know, you can go to underground maths, and it's called Teddy Bear. And I should say that actually the question actually is, here are, I don't know, 12 circles or whatever, and here are 14 equations. Which ones of them are not represented on the diagram? That's the whole thing. But I thought if I gave you all 12, you might leave the room. So, talk to the person next to you. Which sort of thinking did you use? Were there any others again that aren't on the list that you used this time? Visualizing. Yeah, we didn't have visualizing before, did we? Anything else? Collaboration. Yeah, I don't think you're right on that one. Yeah. Specializing. So going from a general equation that you know and then specializing, finding the actual event. Anything else? Go on. Understanding. Understanding the question. Yes. Yeah, exactly. Measuring. Bit of measuring maybe. Yes, at the back. Checking. Yeah, which is an important part. Yeah. Yes. Well, there's a whole thing on oracy, isn't there, now in the new curriculum. That's going to be in the curriculum as a whole, as in curriculum with a capital C. Eliminating, yeah. Estimating. Yeah, if that's that, is that a bit bigger or a bit smaller, etc. Yeah. Comparing, yeah. So all of these are ways that we really want our students to be able to use their thinking. We want them to have a whole range of different sorts of thinking that we want them to be able to do. So if you look at the three questions that we've just done, the one on the right-hand side was, well, what was the mathematics? What was the knowledge you needed for that? It's not a catch question. Place value, yeah, place value. It was about place value, wasn't it? You had to know about place value, and you had to be able to add two-digit numbers. Okay, and then maybe you had to be able to order numbers so that you knew bigger numbers and smaller numbers. What about the graphs then? What knowledge did you need to have? You had to be able to read a graph. Had to know something about Olympic sports, which you may or may not know. What are sensible values for a given situation? So that goes with the metrics, doesn't it? Yeah. Imagination. And it's quite a lot of trying to work out why there were gaps, maybe. Cultural knowledge, yeah, cultural knowledge. And then what about the last one then? Teddy bear. The equation of a circle. So primary colleagues, it may be quite a long time since you did the equation of a circle. If you made a good fist of that, well done. But you have to know the equation of a circle, and you have to know which bits of the equation of a circle refer to what, don't you? And whether it's x squared minus or x squared plus, and that helps you to determine where the origin is. Okay, so we've got number bonds, we've got multiplication, division facts, we've got naming of parts, we've got algorithms. These are all the sorts of mathematics that we need. And we need to be able to recall them. So our memory is really important. If we don't remember things, then we're not going to be able to apply them. But what we really want is fluency. And fluency is not the same as recall. Fluency is recalling, but being able to use what we're recalling in a variety of different ways. Flexibly applying our mathematical concepts. That's what really we want. And when curriculum team, drafting team, is looking at the curriculum, one of the things that we want to make sure happens is that we have a bit more of that and less of maybe of the remembering. So how are we doing? Well, actually, we're not doing badly. We're not doing badly. The last PISA, 22-23, 15-year-olds ranked 11th in the world of those countries that did it, and were above the OECD average. And in TIMSS, in 23-24, 13, 14-year-olds ranked 6th in the world, and 9, 10-year-olds ranked 9th internationally. So that's not to be sneezed at, is it? Internationally, that's not bad. So why is this true? So if you did 5 hours of maths a week, by the time you get to the end of year 11, you've done 2,145 hours worth of maths, which is, by anybody's means, that's quite a lot of maths. And yet 26%, so 1 in 4 primary children do not achieve the expected standard. That's not a norm reference thing so that some are always going to fail. It's an absolute standard. So 1 in every 4 children do not achieve the expected standard in maths. And 41% of pupils taking GCSE do not achieve a grade 4. It's slightly confused because I've added in the resits there, but they're just as eligible as anybody else to be counted. So 41% of pupils don't get a grade 4 on a sitting. And I think it's even more serious than that, really, because if you look at a higher tier, grade 4, you had to get around 26% of the marks to get a grade 4. And yet grade 4 has amazing exchange value, doesn't it? Because that's the one everybody wants to get. On foundation tier, it's a bit better, but it's still less than half marks. You can get less than half marks, and you've still got your grade 4. So, why is this? Turn to the people on your table and come up with one reason why you think these sorts of things happen. I'm sure I could have left the room and you wouldn't have noticed. The CAR, the Curriculum and Assessment Review. And I have colleagues in the room, so Helen is here and Charlie's here. There are 5 of us who are the drafting team for the maths curriculum. And it's both a privilege and a very heavy load to carry. So you'll remember that the structure happened that there was the Curriculum and Assessment Review took in a lot of evidence from teachers, from educators, from policymakers, from students. It also took in information from experts in the field and came up with their review and its suggestions for the different curriculum areas. And that then went to the DFE and the Secretary of State, and the Secretary of State came back and said, yes, I agree with all of this, etc., 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 or I don't agree with all of this. So the biggie, or the big 2, I think, which are the first 2, stated that they thought, and a lot of people had said, that there was just too much in the curriculum. Just too much stuff, which meant that the overwhelming verbs that teachers used when they were talking about the curriculum was getting through it or covering it. And the result of that is that if you're at the top of the attainment level, probably you're okay because you catch on to things fairly quickly. If it takes you a bit longer to really interpret what's going on, then possibly you never get as far as you should get before you're being moved on to the next thing. And we know that if you're not secure in the small stuff, you're going to have real difficulty later on in the bigger stuff. So you might think that, okay, well, let's, as a curriculum review team, let's take some stuff out. And so then we will be told, well, you're dumbing down. We don't want to be accused of dumbing down because the whole point of taking stuff out is to make sure there is deeper understanding. So that's the one big message, which the CAR said, and because it's evolution, not revolution, we are doing what we're told, and we have looked to see what we can do to the Key Stage 1 curriculum, the Key Stage 2 curriculum, and the Key Stage 3 curriculum to make it a more attainable set of content. The CAR also said that there needed to be a focus on mastery, and we see that whole idea of deepening as being the same as having real mastery of something. The CAR proposed a mandatory Year 8 diagnostic test. At Year 8, in order to have Year 9 to be able to do a bit of remedial work, possibly, before students then starting their GCSE course. The DFE decided that there were too many mandatory tests, and so they have now decided it's going to make it flexible, and it won't be a national test at all, but it will be something that schools can use if they want to. And we don't know yet who's going to be writing those, whether there's going to be a central test or whether different awarding organisations or anybody else might be writing it. One of the things that came out really strongly in the CAR, which came out from pupils and especially from parents, was that students left school being financially pretty illiterate. And so the whole thing about financial literacy, which sits within the citizenship curriculum, needs to be bumped up. So as a drafting group, we've been talking to the citizenship team to make sure that the mathematics that they're going to need in financial education, they have seen it first in the mathematics lessons, so that the people who are teaching citizenship don't also have to teach percentages or whatever it is. So it's evolution, not revolution. We're aiming to give more time for deeper, more secure learning of the core mathematical ideas, moving content from Key Stage 1 into Key Stage 2, Key Stage 2 into Key Stage 3. Of course, it's not a sort of a cut, because it's a sort of a gradation. So instead of not meeting something, they'll meet it in a sort of an introductory way and then meet it in a more secure way later. Looking at the split between GCSE Foundation and higher content, so one of the things that we're charged with doing is to look at not only the Key Stage 4 curriculum, but also what goes into the GCSE content, and looking again at can we make that feel a bit more equitable. So this buys time to focus the curriculum on reasoning and mathematical thinking. Doesn't mean to say they haven't got to know it. They're still going to have to know stuff. They're still going to have to remember stuff. They're still going to have to be fluent with their times tables and all the rest of it. But we're going to have a bit more time to let them go deeper and look at better problem-solving opportunities than they would have. And we're also talking to Ofqual and STA, looking at the curricula and the assessments that happen at GCSE and at the end of Key Stage 2 to see whether there are ways that we can make those more equitable and that they are more closely going to resemble what we really want students to learn. There are 2 or 3 other things that are in there which are sort of, I suppose, slightly less important. The red one is the one that at the moment the CAR is looking at, the DFE is looking at rather. Should there be a stepping stone level 1 qualification for students who have not achieved a grade 4 GCSE at 16? I think the jury's out on that. Some people think that's a great idea, so that they've got a new chance to try some different maths in a slightly more relaxed way. Others think that it should be something that happens before they take their GCSE rather than letting them not achieve a grade 4 and then having to do something else. Formula sheets. We've been talking to some of the other subject areas about what specifically science. And there seems to be 2 sorts of formulae. Those that really are important for students to know, because if they don't know them, it means they really don't understand the maths. So like Pythagoras' theorem, if you can't remember Pythagoras' theorem, you probably don't really understand Pythagoras' theorem. But then quadratic formula, if you're nervous in an exam, you might easily get that wrong. So that might be one of the ones you really want students to have. And the re-evaluation of Progress 8, that's nothing to do with us, that's to do with evaluation strategies. This was ChatGPT. And I wonder how many of those, hand on heart, we could say that our curriculum really delivers. We are certainly not going to be able to do it all, and I'm sure we'll make more enemies than we make friends when it all comes out. But if we can only get closer to some of those, then I think we'll have done a good job. Thank you very much.